Rent-a-hal, multi-user, soho, IPI, speech AI interface version 26.
Enterprise artificial intelligence currently relies on a gravity well deployment model. Massive volumes of localized data are continuously pulled into centralized data centers for processing. For regulated industries, sending data to external servers breaks the security perimeter. Client communications, patient health records, and proprietary legal discovery become vulnerable to prompt leakage and external compliance violations. To protect sensitive records, the compute must run locally on the edge. But traditional operating systems act as an immediate bottleneck. Legacy systems rely on rigid process trees. When an AI attempts to execute an intent, it translates that action into sequential system calls. Requests end up waiting in a queue. This sequential blocking generates latency loops, destroying the real-time fluidity required for natural voice interactions. You cannot run highly dynamic language models efficiently on architecture engineered for a keyboard and a mouse. The solution is the Real-Time Agentic Intent OS, or RTAIOS, demonstrated by its reference implementation, rent-a-hal. The objective is a localized system that answers instantly, executes intent directly, and requires zero external cloud dependency. Rent-a-hal achieves this by stripping out imperative coding. It replaces legacy software scripts with an algebraic event bus. The entire architecture is engineered to run efficiently on standard consumer-grade RTX gaming graphics cards. To scale past the strict VRAM limitations of a single consumer GPU, these independent machines network together into a self-healing, push-driven peer-to-peer federation. The architecture brings the sovereign compute directly to the isolated data. Hard-coded logic trees are replaced by a mathematical specification. Every system capability is defined as a tuple. An object multiplied by a verb equals an action. When that intent strikes the event bus, it lights up multiple independent nodes simultaneously, processing the raw event in parallel. This parallel execution relies on a strict publish never raises rule. The publisher of an event is entirely decoupled from the subscriber. If a specific node executes a heavy network query, the asynchronous decoupling prevents that slow downstream task from hanging the core orchestration. Using a safe queue pattern, the system streams an active language model response while simultaneously preparing the next asynchronous intent. By treating the OS as an asynchronous bus, the AI navigates system resources as a mathematical space rather than a series of blocking API calls. To maintain high uptime and instant recovery, the rent-a-hal core operates in a largely stateless manner. Persistent configuration and user memory are managed as scoped state. The system assigns unique alphanumeric GUINs to isolate individual users and tasks. A retrieval augmented generation query searches documents strictly within its walled garden. It cannot access adjacent data pools. Cross-pollination between different user sessions or distinct legal cases on the same network is mathematically impossible. Cryptographically siloed state establishes the exact zero-leak perimeter mandated by enterprise compliance frameworks. The primary physical bottleneck for local execution is the VRAM constraint of a single GPU when managing multi-user concurrency. Network federation distributes the load, but traditional centralized polling generates excessive network overhead. Rent-a-hal bypasses polling entirely by using a push-driven check-in protocol. Member nodes continuously post their specific telemetry to the federator. This payload includes the language model average time, text-to-speech average time, and the current token output count. A startup jitter parameter randomizes the exact timing of these check-ins. This prevents thundering herd scenarios if multiple nodes restart simultaneously. The central federator maintains an in-memory matrix, updating a continuous arg-min calculation to rank the best-performing peers. This push telemetry immediately routes processing overflow to the optimal peer without generating centralized polling requests. Routing logic depends strictly on local performance thresholds. When a node's average exceeds 31 seconds, it triggers an overflow route. A pre-flight probe verifies the receiving peer is capable. Requests carry a Federation hop limit header. The receiving node honors this limit, stopping any further routing to prevent a network cascade. If the designated rescue peer completely drops off the network, the system activates a local failsafe. The missing node receives a degraded average sentinel value. A watchdog forces the intent back to local hardware, executing a fallback to an ultralight model. The architecture guarantees observable, graceful degradation of service rather than total system failure. This is the system terminal, displaying the operating environment in production. The status block monitors live telemetry, displaying the active Federation state, health status, and rolling AI generation times. This interface monitors a fully operational cluster, managing concurrent queries without a single connection to the wide area network. The system's architect commands absolute operational control over the environment. This architecture terminates the cycle of operating expense drift. Recurring metered cloud costs are replaced by the capitalized procurement of commodity hardware. The organization maintains physical sovereignty over its user telemetry and internal business logic. For real-time agentic execution, the future is edge federated.
So imagine for a second that you hire like a really top-tier personal assistant.
Okay, sounds great so far.
Right. And they organize your files, they draft all your most sensitive emails, analyze your financial records, and, they answer every complex question you have instantly.
The dream.
Yeah, exactly. But there is a massive catch here. At the end of every day, this brilliant assistant quietly goes back to like a massive corporate headquarters.
Oh, I see where you're going with this.
Yeah, and they report every single thing you asked them and every document you showed them straight to a board of directors. You don't actually own this assistant.
Right, you're just renting them.
Exactly, you just rent them. And in exchange for all that intelligence, you've essentially agreed to surveillance as a service.
That is a terrifying but very accurate way to frame it.
Well, what if you could fire that spy and just build your own assistant from the ground up? That is exactly what we are unpacking for you in today's deep dive.
Yeah, this is a fascinating one.
We have a stack of technical manuals, white papers, and release notes from June of 2026. And the subject is a piece of software called rent-a-hal Personal Edition version 1.0.
Developed by Jim Ames at N2NHU Labs in Newburgh, New York.
That's the one. Our mission today is to really explore this radical, completely local alternative to cloud-based AI.
Because it's trying to figure out how to turn a standard consumer PC into a multi-user, voice-first computer that you own entirely, right?
Yes, exactly. No subscriptions, no data harvesting, just yours.
And, the defining tension of the digital era right now is trading our private context for the convenience of massive data centers.
Right, we just hand it all over.
Yeah, we've all just accepted this implicit contract where intelligence has to live in the cloud. But what makes the documentation for Rente so compelling is that it completely rejects that premise.
It really does. It's not just a chatbot wrapper that pings a server somewhere.
Not at all. It is an entirely self-contained architecture. It's designed with zero cloud dependency and absolutely no data harvesting.
It's basically the Star Trek computer, but just sitting on a desk in your home or office.
Which is exactly what the creator was going for.
Yeah, the sources actually lean into that hard. To understand why this system operates so fundamentally differently from, like, your standard Siri or ChatGPT, you have to look at the origin story.
Right, it starts way back in 1976.
Yeah, with an 11-year-old kid named Jim Ames. He's sitting in a shed in Jay, Oklahoma, and he's building a cardboard computer inspired by the Star Trek Enterprise.
Just a kid with a dream of a real interacting machine.
Exactly. He wanted a machine that didn't just run programs, but actually understood intent and served the crew. And fast forward 50 years, rent-a-hal is the realization of that dream.
And the core architecture is even called the MTOR, right, which stands for Multitronic Operating Realm.
Yes. A very deliberate nod to the M5 computer from the original Star Trek series.
Though the documentation makes it very clear they kept humans safely in the loop this time around. We don't want a rogue M5 situation.
No, definitely not. But what really grounds this childhood dream is the hardware reality. The developers didn't design this for some multi-million-dollar server rack.
No, it runs on Windows 11.
Right. Specifically, the baseline requirement is just an NVIDIA RTX GPU, something like a 4060 with 8 gigabytes of video RAM and 16 gigs of standard system RAM.
Which is basically just a mid-range gaming PC. It's incredibly accessible hardware.
It really is. But let's break down those specs a bit, because throwing an entire AI on a consumer graphics card requires some heavy optimization.
Oh, absolutely. It's not easy.
The sources say it leverages Meta's Llama 3 8 billion parameter instruct model via a framework called GPT-4All, and then it uses a local Kokoro microservice for the text-to-speech.
Right.
I know 8 billion parameters sounds like a lot to a layperson, but in the AI world, that's actually quite compact, isn't it?
It's incredibly compact. I mean, the models powering the major cloud platforms often have hundreds of billions or even over a trillion parameters.
Wow, over a
From a-
trillion.
Yeah, and those require massive server farms just to hold the model in memory. So an 8 billion parameter model is really the sweet spot.
Because it fits on the card.
Exactly. It's small enough to physically fit inside that 8 gigabytes of VRAM on a desktop graphics card, but it's sophisticated enough to actually understand nuance, parse language, and, reason through logic.
And that's where GPT-4All comes in.
Yeah, GPT-4All is the engine that allows that model to run efficiently on local consumer hardware without needing all that enterprise-grade infrastructure.
Okay, got it. And the Kokoro microservice.
That simply handles generating natural-sounding audio locally, so your voice data never leaves the machine.
Okay, so the hardware is accessible, which is great, but the sources spend a lot of time explaining that to make this actually work smoothly, they had to throw out the traditional operating system model entirely.
Yeah, they outline this concept called algebraic design.
Right. They reject the standard application-centric model of computing, which is, how we all use computers today. Clicking icons to open apps.
Which is very resource heavy.
Yeah, and they replace it with an intent-centric algebraic equation. It's object times verb equals action.
It's a fundamental shift in how the machine processes commands.
When I first read that in the white papers, it felt like a logic puzzle. How does that equation actually change the way the computer processes my voice?
Well, to grasp the shift, you have to look at the bottlenecks in a traditional operating system. Current OS architectures are heavily process-oriented.
Okay.
They rely on rigid process trees and permission layers. So if an AI agent wants to accomplish a task for you on a standard Windows or Mac machine, it has to translate its intent into these really clunky system calls.
Like it has to ask for permission for everything.
Exactly. It has to spawn a process, ask the kernel for memory, compete with your antivirus software and background updates, and then wait for the system to allocate resources.
Jeez.
Yeah, the OS treats the AI like any other dumb application waiting in line.
I think I see where this is going. It's like this really rigid corporate bureaucracy.
That's a great way to put it.
The AI assistant wants to tell me the weather, but first it has to fill out Form 27B in triplicate, submit it to the kernel manager, wait in the lobby, and then eventually get approved to display a window on my screen.
That is a very fair way to conceptualize the friction.
Yeah.
And that friction causes a lot of latency.
Right.
So N2NHU Labs bypasses those traditional application constraints entirely by using what they call a typed event bus.
A typed event bus. Okay, what is that?
In this architecture, every single user action is strictly defined as a tuple, a pairing of an object and a verb. The system doesn't launch programs at all. It orchestrates intents across this bus.
So if the old way is a bureaucracy, this event bus feels more like maybe a bustling town square.
I like that. How so?
Well, instead of the AI filling out paperwork to open a weather app, it just steps into the square and shouts, "I have an intent. The object is weather. The verb is fetch."
Exactly.
And then whoever in that square is explicitly built to handle weather requests instantly grabs it and does the work asynchronously.
You are hitting on the core efficiency of the MTOR architecture right there. Events move across this bus as typed objects, and they're processed in parallel by specific modules.
Wow, that's so much faster.
It completely removes the middleman of the traditional graphical user interface.
Yeah.
You aren't opening software anymore. You're directly addressing capabilities.
Yeah.
And that's what makes the interface feel instantaneous.
Which brings us to what it actually feels like for you, the user, to interact with it. Because you don't have to install bulky desktop software on every phone or tablet in your house.
Right, it's all network-based.
Yeah, you interact with the system through a web-based cockpit. Any device on your local network just navigates to a local URL, and you are greeted with this sleek, dark mode terminal.
Very sci-fi.
Very. You just say the wake word, computer, ask your question, and say new line to submit it.
Simple and plain.
But what really jumped out at me from the technical notes is how it handles the processing. It explicitly does not send every single question to the large language model.
And honestly, it shouldn't. Using an advanced neural network to just check the temperature outside or play a song, is a massive waste of computational power.
Right, it's overkill.
It's the equivalent of using a supercomputer to do basic addition. The developers recognize that consumer GPUs have hard limits, so they built in specific realms.
Realms, right, the handlers.
Yeah, these handlers completely bypass the LLM for deterministic tasks.
Yeah, the sources list a few of these specific realms. Like, if you ask for the weather, the event bus instantly routes that intent directly to Open Weather Map via an API.
Right, so the AI doesn't even have to think about it.
It never touches the AI's brain. And if you ask for music, it executes a background DuckDuckGo search and embeds a YouTube video directly into your local cockpit terminal.
Which is so seamless.
Or if you say you need to find a nearby pharmacy, it just hits OpenStreetMap for the service finder. It actively hoards the heavy AI processing power, saving it only for complex reasoning or drafting tasks.
It's a very disciplined approach to resource management. And that discipline is vital because, remember, this is a multi-user system.
Right, multiple people talking to the same box.
Exactly. The documentation emphasizes transparency in how it handles a household or an office, all talking to the same machine. Every user on the local network is assigned a specific ID, a user_GID.
Which solves a huge headache because if I ask it to play a podcast in the kitchen, it doesn't accidentally blast out of my colleague's speakers in the next room.
Right. It knows exactly which terminal issued the intent.
And the interface doesn't hide the processing load either. They call it honest metrics.
Yeah, most modern UI design tries to abstract away the processing time, right, with a spinning beach ball or a generic loading bar.
Yeah, just to keep you distracted.
Rent-a-hal completely rejects that.
Yeah.
If the AI queue is backed up because 3 different users submitted heavy reasoning tasks at the exact same moment, everyone sees the real-time queue.
So you know why it's taking the second.
Exactly. The status indicator visually shifts from green to amber to red, showing exactly how many queries are pending.
It refuses to lie to you about its capacity. They
Yeah.
love that. And there are some very pragmatic safety features baked into this UI, too.
Oh, the safety features are great.
There is this massive red silence button right on the cockpit screen that instantly kills all audio generation across the board.
A literal panic button for audio.
Yeah. Plus, they use doubled action words for voice commands. You can't just say stop to cancel an ongoing process because you might just use the word stop naturally while you're dictating a document.
That makes total sense.
So you have to say stop, stop, or repeat to actually trigger the system voice commands. It's built for actual human speech patterns, not perfect laboratory conditions.
It is heavily focused on practical usability. And that extends to how developers interact with it as well.
Oh, right, the API.
The API is remarkably stripped down. The sources actually highlight a specific anecdote about a 9-year-old named Little Johnny to demonstrate this.
Yeah, the Little Johnny example blew my mind. Because the system is entirely local and operates on your own network, a kid can build a fully functional AI application in literally 5 lines of HTML.
It's incredible. Let's look at the mechanics of why that's even possible.
Please do, because it sounds like magic.
Well, in the cloud ecosystem, if you want to build an AI app, you have to register for a developer account, set up OAuth authentications, input a credit card, and secure an API key just to get permission to send a request to the server.
It's a huge barrier to entry.
Massive.
Uh,
But with rent-a-hal, the endpoint is just sitting on your local network's IP address. Little Johnny's 5 lines of HTML simply point directly at that local port.
just boom, connected.
Right. There are no gatekeepers.
But, you know, making the system that radically open and easy to access brings up a totally different problem.
What's that?
Well, how do you know the complex AI engine sitting behind that local port is actually awake and functioning before you rely on it?
Yes. The boot process.
Yeah. The white papers go into deep detail on system reliability, specifically outlining this boot wizard with 5 hard gates. And the most interesting one to me was the completion probe.
That is a crucial feature.
If I'm reading the technical jargon right, this isn't just checking if the software is installed, is it?
Not at all.
Yeah.
Most standard installer packages just verify that a model file exists on your hard drive.
Right.
And if the file path is correct, they declare the system ready.
Yeah, just checking the box.
Exactly.
Yeah.
rent-a-hal doesn't trust the file path. The completion probe forces the large language model to actually process and answer a test prompt.
Oh, wow.
And it must successfully return a coherent answer within 15 seconds. If it fails to do that, the system is strictly blocked from launching.
It actively prevents that incredibly frustrating loaded but broken state. We've all experienced that with smart speakers.
Constantly.
You see the light ring turn on, you assume it's listening, you talk into the void, and absolutely nothing happens because the back end is secretly frozen.
It's infuriating.
But this software forces the AI to prove it's conscious before it even lets you use it.
It enforces honest signaling. The system would much rather give you a hard, immediate failure notice than string you along with a silent malfunction.
I really love the philosophy behind that. But look, we do have to address the hardware limitations here.
Yeah, the elephant in the room.
We established that this entire system runs on a consumer-grade RTX 4060 GPU with 8 gigs of memory. That's a solid graphics card for a single user.
Very capable for one person, yes.
But if we're talking about deploying this in a busy office, say a dental clinic, where a doctor and 2 hygienists all ask the AI to summarize different patient histories at the exact same second that 8-gigabyte GPU is going to hit a wall and bottleneck hard.
Oh, absolutely. It would choke.
Cloud providers solve concurrency by just routing the overflow to another server rack in their massive data centers.
No.
So how did N2 and HE Labs bypass this strict hardware limit without violating their own privacy rules and sending your data to the cloud?
They solved it by looking outward to the local network instead of upward to the cloud. This is where the MTOR Federation comes in.
The MTOR Federation.
Yeah, it's a push-driven, decentralized, peer-to-peer mesh architecture.
Okay, walk me through how that actually functions when the system gets overloaded.
So the system constantly monitors its own latency. If your local AI engine gets bogged down specifically, the white papers say the threshold is if your rolling average response time climbs over 31 seconds, your local instance acts.
What does it do?
It will autonomously attempt to temporarily borrow processing power from a trusted peer on your mesh network.
Like another computer in the building.
Exactly. You could link your machine up with a second PC down the hall in your office, or even a friend's system securely connected across town.
So if my single GPU is choking on 3 simultaneous requests, it just hands one of those requests over to my colleague's idle machine to process.
Precisely. But it's entirely cooperative and requires pre-authorization. And because it's operating in a decentralized mesh, they had to engineer strict protocols to prevent network chaos.
Right, because that could get messy fast.
Very messy.
Yeah.
The most critical safeguard they implemented is a header called X Federation Hops. 1.
X Federation Ops. 1, let me guess. If you have a whole network of these machines, you could run into a scenario where machine A is overloaded and hands a task to machine B.
Right.
But machine B is also overloaded, so it passes it to machine C, which passes it right back to machine A. You'd get an endless loop. Does that hops 1 limit prevent that?
You've got the exact logic. By hard-coding a strict 1-hop limit, every forwarded request carries a flag that essentially says, I've already been delegated once, do not delegate me again, process me or fail.
Wow.
It makes infinite cascading loops mathematically impossible.
That is incredibly elegant. But there is another mechanism in the Federation chapter that fascinated me. It's called the bounded silent dependency, also known as the degraded watchdog.
Oh, yes. The watchdog.
At first, I thought that just meant the AI was running slowly, but it's actually a deliberate failsafe built into the system to manage peer reliance, isn't it?
It is. It's a really fascinating approach to network health. If your local AI engine completely crashes or freezes, the MTOR Federation will seamlessly step in to rescue your queries.
So the user doesn't even notice at first.
Exactly. Your authorized peers will quietly process your intents for you, and your interface will continue to work perfectly. But the system is watching the clock.
And it only gives you a tiny window, right?
5 minutes of wall clock time. If you rely entirely on your peers for 5 continuous minutes, the degraded watchdog triggers.
And what happens then?
It actively severs your connection to the Federation and forces your local system to fall back to a visibly degraded floor.
It purposefully breaks your connection to the working network. It drops your slick Kokoro voice synthesis down to this robotic, old-school Pitpsych 3 voice, or it throws a stark echo error message right in your cockpit.
Yeah, the system fundamentally refuses to let you silently leech off the network indefinitely without forcing you to acknowledge that your own hardware is broken.
It almost feels like, okay, say you have a neighbor with a fantastic top-of-the-line lawnmower.
Okay, I'm tracking.
If my lawnmower breaks on a Saturday, I can borrow my neighbor's mower to quickly finish my yard. The neighborhood supports me.
Right, it's a favor.
But if I try to just silently borrow their lawnmower every single day for a week without fixing mine, the neighborhood watch steps in, locks their shed, and forces me to finally deal with my own broken machine.
That is the perfect analogy. It forces you to be an honest participant in the mesh. You cannot hide your failure.
You have to fix your stuff.
Right. It forces the operator to see the truth, diagnose the local engine, and fix the bottleneck. And the beauty of the design is that the moment your local engine successfully processes a query on its own, the watchdog automatically clears itself and normal Federation routing resumes.
So it's totally self-healing.
The network is self-healing, yes, but it demands accountability from every node.
Okay, so the underlying architecture is incredibly robust, and the neighborhood federation solves the hardware scaling problem. But let's look at the broader market.
Yeah, who is this actually for?
Exactly. Who actually needs to go through the effort of setting up sovereign computing in 2026? Microsoft or Google would be more than happy to just sell an Office and enterprise cloud license.
True.
The author of the source material actually provides a very refreshing, honest summary matrix comparing rent-a-hal to the giants.
It's rare to see developer documentation pull so few punches about its own limitations. The author openly admits where the cloud competitors have the distinct advantage.
Yeah, they acknowledge right up front that ChatGPT's advanced voice mode is still superior for highly natural, emotive, interrupting conversation.
Because it processes audio natively without converting it to text first.
Right, and if your main goal is controlling a massive smart home, Alexa Plus and Google Gemini for Home are vastly superior.
They natively support over 100,000 smart devices.
Yeah, rent-a-hal isn't really engineered to seamlessly integrate with your kitchen lights and your smart thermostat out of the box.
No, its primary purpose.
And of course, if you are deeply embedded in the Apple ecosystem, Siri is still going to be your best bet for mobile integration.
So they concede the mainstream consumer convenience market. But where rent-a-hal definitively wins, and where the enterprise cloud models fail completely, is serving privacy-first individuals and highly regulated professionals.
The people who can't compromise.
Exactly. It is built for entities that absolutely cannot, legally or ethically, allow their data to leave the physical building.
The sources outline some very specific business use cases for this. Law firms are a massive one.
Oh, absolutely.
The legal profession has been terrified of AI because of the risk of prompt leakage, the very real danger that confidential deposition details might be used to train a public model or accidentally leak out onto the public internet.
It's a huge liability.
But with rent-a-hal, an attorney can spin up a per-case isolated realm. They can dump thousands of pages of highly sensitive discovery documents into the system and analyze them instantly with absolute mathematical certainty that the data physically never crossed a firewall.
It eliminates the risk of a third-party data breach entirely. And you see a similar paradigm in healthcare, too.
Oh, definitely.
Dental clinics, mental health practices, local specialists, they can use this architecture to handle local charting, generate clinical summaries, and manage shift handoffs while maintaining incredibly strict high-peak compliance.
Because the data literally doesn't leave the room.
Right. The protected health information, the PHI, never touches a server farm.
And that opens up a massive opportunity for the IT industry, specifically managed service providers, or MSPs.
The white papers refer to this as managed sovereign AI.
Managed sovereign AI.
Yeah, an MSP can deploy these hardware clusters into small businesses, creating a brand new revenue stream. They manage the physical hardware, ensure the network uptime, and handle the federation routing.
But they don't see the data.
Exactly. They do all that without ever taking on the massive liability of actually hosting or being able to see the client-sensitive data.
And when you look at the economics for those small businesses, the argument becomes incredibly compelling.
The math is very favorable.
A typical enterprise cloud AI subscription might cost $20 to $30 a month per user. For a mid-sized law firm or a busy clinic, that operational expense spirals out of control quickly year after year.
It just never stops.
But with this system, the business makes a one-time hardware purchase. The sources estimate it takes around $3,900 to build a fully redundant two-realm local cluster.
Which is a drop in the bucket for a successful firm.
Right. And once you buy those boxes, your ongoing marginal cost per query is literally just the electricity it takes to run the graphics card. It shifts AI from a never-ending rental fee back to an owned physical asset.
The return on investment becomes undeniable the moment you eliminate that relentless operating expense drift.
So zooming out and looking at the core takeaway from all these technical documents, the release notes, the architecture, rent-a-hal isn't actually trying to destroy the cloud.
No, not at all.
The goal isn't to take down the massive data centers.
The goal is to force the entire ecosystem to mature. The legacy model of the early 2020s relied entirely on a gravity well architecture, right?
Pulling everything to the center.
Exactly. Pull all the users' data to the center, monetize the heavy compute, and lock the user into a subscription. Rent-a-hal proves that inference, the actual thinking and reasoning part of the AI, does not require a centralized data center anymore.
It pushes the intelligence all the way out to the edge of the network.
It is the ultimate reclamation of digital ownership.
In an age where every smart TV, every phone, and every digital assistant is a potential surveillance tool feeding a corporate database, having the option to run a highly capable, intent-driven operating system entirely within the four walls of your own home or office is profound.
It really is.
It brings us right back to that brilliant personal assistant we talked about at the start. Only this time, when they close the door to your office at the end of the day, they don't call the corporate board to report on what you read.
Look,
They just go to sleep right there under your desk. They work for you and only you.
it proves that absolute privacy can be a baseline architectural requirement, rather than just an optional settings toggle that a corporation can quietly switch off whenever their business model changes.
And it leaves you with a pretty wild final thought to ponder as we wrap up.
What's that?
Well, as consumer hardware gets even cheaper and these models get even more efficient over the next few years, what happens if thousands of these local, privately owned AI federations begin to voluntarily link up their unused GPU cycles across entire cities?
Oh, wow.
Could a grassroots neighborhood mesh of standard consumer computers eventually rival the processing power and the knowledge synthesis of the largest tech monopolies on Earth?
That is a massive idea.
And could they actually pull it off without ever sacrificing a single drop of our personal privacy? Something to think about the next time you ask the cloud to set a timer.